Welcome to The Explainer. If you're running an industrial facility, you already know that overhead costs have a nasty habit of sneaking up on you. And honestly, electricity, that is usually one of the biggest culprits. Today, we're setting the stage for a seriously eye-opening breakdown of industrial energy savings. We're going to look under the hood at the data and the engineering behind Rotomotive's high-efficiency motors, specifically focusing on their IE3 and IE4 product lines. We'll unpack exactly how the nitty-gritty science of power transmission literally translates into massive financial and environmental returns. So settle in and let's jump right into it. So what if a single equipment upgrade could cut your power costs by roughly 20%? Right? For facility managers, plant operators, or any business owner who's hyper-focused on keeping operational overhead in check, this absolutely isn't just a hypothetical scenario. Look, in India, with limited energy resources and the frankly massive costs of adding new generation capacity, electrical energy costs are just climbing. It's a steady upward crawl. To fight back, switching to what the Bureau of Indian Standards officially calls energy-efficient motors, specifically those IE2 and IE3 categories, well, it's no longer just a nice-to-have upgrade. It's become an absolute strategic necessity for your bottom line. Okay, let's dive into this specific number here. 8,000 rupees. What this represents is the direct, incredibly tangible annual power cost saving for just one single 15-kilowatt IE3 motor that's operating for about 6,000 hours a year. Because these IE3 level motors slash power costs by about 20%, that one single motor is saving you roughly 2 megawatt hours of energy every single year. Now, just take a second and imagine multiplying that 8,000 rupee saving by the dozens or maybe even hundreds of motors humming away across a massive manufacturing floor. The immediate savings in power costs are just staggering. You're essentially transforming what used to be a completely fixed utility expense right into retained capital for your business.
Section 1. Lifting the Hood, the IE3 Efficiency Advantage.
To really grasp how we're hitting those numbers, we have to look closely at the engineering. High efficiency in electric motors is, at its core, just a measure of how successfully we can convert input electrical power into output mechanical energy, all while minimizing the losses that just sort of escape as heat. Inside a high-efficiency motor like this one, there's no magic trick. It's all about the meticulous reduction of frictional losses. You've got a dynamically balanced rotor, a heavily minimized air gap between the rotor and stator, and windings that use a much higher conductor diameter. On top of that, those windings are vacuum impregnated under high pressure with Class F insulating enamel, which gives them this incredibly high resistance to electrical and thermal stress. Every single internal component is tweaked and optimized so that way less energy is consumed to produce the exact same amount of torque at the shaft.
Section 2. The Microscale Difference, the CRNO Lamination Secret.
To find the real secret sauce behind this efficiency, we actually have to zoom way in on the single raw material that truly dictates the motor's performance: the magnetic laminations. Just look at the level of precision happening here. When it comes to these magnetic laminations, thinner sheets equal much, much higher performance. Now, standard motors, they often just use semi-processed or decarb lamination sheets, but Rotomotive utilizes silicon magnetic laminations, specifically cold-rolled non-oriented, or CRNO sheets. Choosing this specific material, combined with insanely exacting thickness standards, drastically changes how the motor handles magnetic fields.
And this brilliantly illustrates the contrast. It's genuinely staggering. Over on the left, standard semi-processed laminations can be up to 1.0 millimeters thick. And surprisingly enough, there isn't even a standard that prescribes a maximum watts loss factor for them. But look on the right. Rotomotive's CRNO magnetic laminations have a strictly controlled 0.5 millimeter maximum thickness, literally half the thickness. Because of this, the watts loss factor for the standard material is generally double that of the CRNO sheets used here. Let's break down the domino effect of using these ultra-thin 0.5 millimeter CRNO laminations. The material composition, paired with that thinness, results in a very low watts loss per kilogram. Lower specific losses simply mean the motor needs way less magnetizing current to get the exact same power and torque output. And less current, that means significantly less heating. This massive drop in thermal stress actually slows down the aging of the insulating materials inside. It's this exact, precise chain reaction that directly translates into that 20% power savings we were talking about earlier. Okay, let's keep moving and see how this builds into an entirely different class of technology. Section 3. The Next Level. IE4 Super Premium Efficiency.
If IE3 basically perfected the induction motor, well, IE4 changes the paradigm entirely. It uses the PMSM, or permanent magnet synchronous motor, to squeeze out absolutely every last drop of performance. Think of it kind of like a hybrid. Much like a brushless DC motor, it features a permanent magnet rotor and windings on the stator. However, its physical structure produces a really smooth, wave-like magnetic field, a sinusoidal flux density, exactly like an induction motor. But here's the kicker. Because field excitation comes purely from permanent magnets, there is absolutely zero stator power dedicated to producing the magnetic field. This gives the PMSM a significantly higher power density than standard induction motors that have the exact same ratings. Looking at Rotomotive's high-performance IE4 PMSM, those permanent magnets give it a really remarkable capability. They can actually generate full torque even at zero speed. Because they're controlled by a digital inverter, they offer incredibly high-performance motor control. You get beautifully smooth rotation over the entire speed range, super fast acceleration, and rapid deceleration. So it's not just more efficient, it's vastly more responsive to the real-time demands of your application.
Now, what's really interesting about this slide is the actual chemistry happening inside the rotor. You see, there are a few different classes of permanent magnets, but the PMSM utilizes rare earth materials, specifically neodymium iron boron, or NdFeB. The latest, cutting-edge grades of these NdFeB magnets are what truly catapult the PMSM into that ultra-elite super premium IE4 efficiency tier. They boast a tremendously high remnant magnetic flux density and fantastic thermal stability. And thanks to specialized metallic or resin coatings, they are highly resistant to corrosion. This protects the interior magnet rotor against intense centrifugal forces and really extreme operational environments.
Section 4, the long game, durability and environmental impact. Let's connect all this cutting-edge engineering back to your facility's long-term health and, of course, your broader green energy goals. High-efficiency motors aren't just a quick overnight cost-cutting measure, they are a serious investment in resilience. 12 years. That is the expected operational lifespan for these motors, and that's assuming a heavy average operation of 2,500 hours a year for motors up to 15 kilowatts, and a whopping 4,000 hours a year for the higher-rated ones. You might be wondering, why on earth do they last so incredibly long? Well, as we've learned, higher efficiency directly means less wasted energy. Less wasted energy means less heat generation. Because they run so much cooler, the aging process of the internal insulating materials is drastically slowed down, prolonging the motor's reliability and extending its life well over a decade.
So, the crucial point is this. Cutting your power usage isn't just fantastic for your operational wallet, it actively preserves our resources and protects the environment. By embracing these IE3 and IE4 efficiency standards, you are significantly reducing the energy consumption that directly generates CO2 emissions. It's a total win-win situation. You're improving the health of your company's bottom line while simultaneously improving the health of our shared environment.
Which brings us to our final thought for today's explainer. Take a moment to look around your own facility. Are your older, legacy motors secretly draining your operational budget every single hour they're running? We've just seen how precise engineering, everything from those 0.5mm CRNO laminations to the rare earth NdFeB magnets, can literally claw back 20% of your power costs and secure 12 years of rock-solid reliable operation. Honestly, it's time to run the numbers on your own equipment. Thank you so much for joining me today, and I strongly encourage you to calculate your own potential ROI. You might be surprised by what you find.